Welcome, everybody. We've got Sylvia, we've got Jeff, who've generously opened up their home for this exciting version of Silicon Zombies Unplugged. Zombies Unplugged. So great to see you,
Yeah,
Sylvia.
good to see you.
And thank you so much for having us.
Yep.
If you look at all this beautiful artwork, most of it's yours.
It's all mine.
Yeah. And you've got just some incredible pieces, and maybe, who knows, maybe later we could take a quick tour and show some of your favorite pieces.
Yeah, welcome, Emrah.
Yeah.
Always a pleasure.
Excited to have Emrah.
Nice.
Is there a website where folks can check out your artwork?
Yes, it's poloto.com, POLOTO.com.
Poloto.com. Beautiful. We'll include that in the show notes. Awesome. Emrah,
Yeah.
please. All right. Yeah, this is exciting. This is, typically what we do is like a live studio audience, but these kind of feel a little bit more intimate, kind of similar to what we're doing with the Zombies radio, which is pretty fun. So we'll typically say like, we bring you the best brains from the Bay, and the audience goes, and beyond. But, the audience today is, Sylvia and Jeff, and we got Elias and JT helping out with the AV. Well, because we demystify emerging technology, and Emrah Gultekin, CEO and founder of Chooch AI.
Chairman right now.
Chairman. Okay. Is really kind of focusing on the next iteration of what is computer vision and how to continue to drive that forward. And the applications, you said, have changed drastically in the last couple of years. So maybe before we dive into all that, you could share a little bit about yourself and maybe the genesis of Chooch, if you could.
Yeah, thank you, Nick. It's a great pleasure being here with you, and I've been following Silicon Zombies for a while. We met over a year ago at Matthew Stepka's house,
Yeah.
So that was interesting. Basically, it really started with visual search, and this was back 2015, 2016. And we had a client who wanted to actually do searches inside of videos and images as well. So that's kind of how it started. It's a very client-based start of the company, and
Sure.
we had done a lot with search at the time. And so what we did was we said, hey, this is an interesting problem. Like, well, how do you really do visual search? And there was an explosion of video data, explosion of image data at the time, and currently as well. And so it started out with classification. Obviously, you start classifying these things, and then you can actually do object detection inside of them as well. And then based on that, you can do the searches. So it kind of started with all that, and it goes way back to Stanford 2007 with ImageNet, and then the breakthroughs with AlexNet in 2012, and that really put a lot of momentum into the deep learning systems.
I see.
At the time. But computer vision has been around for a while. OCR, object detection, image classification, and so forth. And we wanted to solve this problem at the time. And what we did was we started training a lot of models with deep learning.
Sure.
And so, but over the last 2-3 years, has been like a shift in computer vision, and the shift has become more of the it's merged with the language models.
I see. So kind of like an intersection too. And maybe now we're able to finally detect a cucumber from a snake for the cats.
Yeah, well, that was like the muffin.
Yeah.
The muffin and
The Chihuahua.
puppies, yeah, Chihuahuas. Yeah.
Yeah, they do look like suspiciously similar.
Yeah, exactly. So you can trick, and that was all like old computer vision models were working that way, where you kind of very kind of deterministic models. CNNs,
Convolutional neural networks. Yeah.
It was before the transformers became important. Transformer, that architecture started in 2017, and it was all language driven.
So does that mean it's like was like diffusion in the past? I mean, can you describe to us what diffusion is? I think that was an important element of computer vision early on, right?
Well, it basically, it had to do with training convolutional neural networks at the time, where it became, you basically had to collect a lot of imagery, collect a lot of videos, and you had to kind of manually
tag.
annotate all of that.
Okay.
And so there was an annotation process, and then there was a training process, and then you have to test it and so forth. And one of the problems with this was that, first of all, it took a long time.
Yeah.
And second, it wasn't that accurate.
Yeah.
It wasn't accurate enough for, certain complex things. So,
Sure.
Cat, dog, okay. But if you want to, detect a fire, or if you want to detect theft, or if you want to detect certain actions, that was
Yeah.
very, very difficult with these models. And so we've had this shift over the, into transformer-based models with the visions with the vision as well. So that's kind of been very exciting for us,
Yeah.
because now we can do a lot more.
Yeah.
It costs less training and so forth, and you can actually, there's a business case around it now, which makes a lot more sense.
Probably a lot more. Like, just over lunch, you mentioned that a lot of the functionality is being pushed out to the edge, and if you combine that with like the collapsing cost, my understanding is that costs to train these models are decreasing about 4x per year. So it feels almost like the more applications, the cheaper it gets, the more applications, which just fuels more of the energy,
Yeah.
Or more, I should say, like the excitement and the utility. So, I mean,
It's
I'm
more
really,
to do
yeah.
with the utility, actually, in vision.
Okay.
Language was, similar in that case, where, kind of you had the old language models, but vision specifically needs to be high utility.
Yeah.
And so that was a barrier until about 2 years ago, and now kind of, but you still kind of struggle with the infrastructure piece, because basically you have a sensor. The
Yeah.
sensor is a camera. And so you have that has to be streaming somewhere, or you do the models on the edge, where the sensor is capturing that data. But at the end of the day, it just made sense to us way back, more than a decade ago, that everything would be moving to vision, because in human evolution too, and how we perceive the world, we perceive about
Yeah.
70-80% of the world through vision.
It's a lot of bits.
It's
Lots of processing
a lot
through the
of
head.
processing.
Yeah.
But one of the mistakes that a lot of people did at the time was like, well, it's the eye. It's anything the human eye can do. And yes, that's the sensor, but what you're really doing in the background is you're processing it in language, because you make sense of the world through your language model,
Yeah.
actually, not your vision model.
Sure.
So the vision model and language model in humans as well have to be interconnected. And
Sure.
so that has been kind of very, very critical in the evolution of computer vision as well, to be able to kind of mimic that process of human cognition into machines.
Yeah, I'm really fascinated by how we can learn from the brain and learn from nature and kind of recreate that in some capacity to solve specific challenges and then commercialize. So like with the advent of, like these, I was going to say multimodal models, but really just like from the start, your interface becomes natural language,
Yes.
which is a huge game changer, right? Because that's going to, correct me if I'm wrong, Emma, but it's almost like software is having its second resurgence, where traditionally the business model is like, maybe if you have 500 people in a company, you can sell 100 licenses at $50 a seat, and you get X revenue per year. But now it seems like software is actually going after labor. So within like the computer vision perspective, if you could say, find me a crack on the solar panel, or predict when there's going to be a challenge with maybe an issue in a construction zone or something like that, that's kind of completely changes the ball game, right?
Yeah. So it is going after labor in that sense, but it's also creating new data that wouldn't have existed. So you have billions of cameras today that are streaming things, and that data is not being captured at all, or it's not being structured. So now you have a way to structure that data, and so you may think you know what the problem is with your enterprise or with your company or with your organization.
Yeah.
But what that data provides might be something else. So I'll give you an example from a
Yeah.
retailer. So the retailer asks, well, we have theft, and so can you detect for theft? And we're like, yeah, we can do that, with these models and so forth. And then once you install the cameras, the customer success people say, well, I can see people, the tracking, we can track the route of people or where they're kind of dwelling and so forth. So you have a secondary thing that comes out of this.
Like input feed,
Yeah, exactly.
feedback.
So yeah, because it's like, well, now the camera, since it can do anything the human eye can do, you can actually come back and say, well, you're solving for this specific problem now, but you're creating all this data that everyone else can use as well
Oh, okay.
in that process. So it's not just going after labor. It's actually creating a new. It's creating a wealth of data that can be mined.
Yeah.
Where you can create correlations and indicators for your business as well. So this data didn't exist before. So you're going for a specific problem,
Yeah.
and you may solve that problem. You may not to 100%, but you're also creating all this other data
Yeah.
that could be consumed by other parts of the organization.
Wow. Yeah, so it's almost like you set out to solve one challenge, but maybe there's like secondary, or tertiary
Yeah.
values. That probably makes it easier to help justify a rollout of Chooch when there's like, you're determining the total cost of ownership, or I guess maybe you could call it like an ROI calculator.
Yeah.
There may be like other ways to justify.
Yeah, exactly. So you can basically divide it into different departments and so forth.
What,
But
Yeah.
it's so fundamental. Like, I mean, the vision stuff. So everything from self-driving, finally we can do robotics better
Yeah.
with vision. You can do all kinds of stuff. So it's more fundamental than just an ROI calculator.
Sure.
It's actually like, oh well, it's like, what's the ROI calculator on your personal computer, or computers that there is no. It's like infinite. Because
The TAM is ginormous.
It's like, if you don't do it, you're going to be left behind.
Sure.
That's the thing.
Yeah.
You won't have the data. You won't be able to.
Oh, yeah, but that's using the stick. I think more people kind of tend to appreciate the
Well, it
carrot,
starts with
right?
ROI.
Yeah.
It has to.
It's got like a business case.
Business case. Yeah.
Yeah.
The business cases have been difficult.
Really?
Yeah. Well, I mean,
Maybe
listen,
people just don't. It's just there's a lot of education that you have to do.
Well, it all started with surveillance and security and all that. So, smart cities, and so what's the business case for that? Slip and fall, is there a crime, is there an accident, and so forth.
Yeah.
So it's not really, something where you can actually
Sure.
pinpoint the ROI very easily.
Yeah. It's just like if you see a banana peel, like we got to pick that up. Somebody's gonna.
Yeah, like trash and whatever, garbage. But it's that, and then you're able to do this with defect detection, with inventory management, with fire detection, and so forth. The ROIs become more clear as you get more specific in terms of your detection and what you're
I
trying to
see.
achieve with computer vision.
Yeah, we were talking about early detection, specifically around fire and then medicine, but let's get to that in just a moment, Emrah. I'm curious about how you mentioned there's billions of cameras. How can we aggregate those and reward people for giving passive footage that maybe you could train like a master model on? Do you know what I mean? Like if there's some way to, like for example, now we're streaming. What if there was some way to easily divert that stream, train a model, and reward the people that are creating the content? Is there any way to kind of do that? Or does that not really make any sense?
So on an enterprise basis, we do this. So we take the customer's data, of course, with their
Sure.
consent and so forth, and we train the models based on that, or we fine tune the models. So that's been happening on the enterprise case, because every enterprise has a different set of data. They do things differently and so forth. So that exists. And one of the things that we do is we make sure that we're able to label that data, we're able to process that data, and also put it up into the streams that for those specific use cases.
I see.
Yeah, so it already exists on the enterprise level, but publicly,
Consumer would be a huge market, right?
Yeah, I mean, we're not in consumers, so we don't know, but
Yeah.
all the social media platforms, they do this already. So
Sure.
they're already training.
Okay.
Everything, all the
That's part of the terms and
the open AIs,
Yeah.
all of them are, they're trained on public data.
yeah.
And so they sort of sound.
Right.
The issue with all of this is, so we're talking about like how we perceive the world, as humans. We view the world, and then we talked about like
processing.
language part of it,
Yeah.
where we kind of understand what's happening. So I know this is a piano, I know that's an orange, and so
Yeah.
forth. But it's even further than that. It goes further than that, and it's also the model of your experience. So you attribute meaning to something based on your own experience.
So if it was fine-tuned, that would mean like if you're a piano expert, then you'd be fine-tuned to understand models or kinds of pianos.
Exactly. So you'd be able to go deeper into that. And so it's very custom in that sense, where you kind of, and it's also what's good, what's bad,
Yeah.
right? What has value, what doesn't, what's advantageous, what's not. So you kind of make these judgments about your environment based on your experiences. So it's not just the viewing, it's the language, and then it's the value of that on the model. So if you talk about how we train these types of models, it has to be custom. If you want to if you're trying to replicate a specific person's expertise
I see.
into these models, or a specific group of people. So if you're doing like surgeons, like
Yeah.
they view the world differently than artists,
Yeah.
and so forth. So
Thank God.
yeah.
So I'm curious a little bit about let's get back to the early detection thing, because I think that probably, can we mention some of the cooler clients you have first, or some of the more kind of like James Bond style,
Well, I mean, one of our first breaks was with the U.S. Air Force.
Yeah.
And it was basically like, they saw we had an app at the time. It was called IC2, and it was basically like early generative AI, where it had bubbles coming up where you're kind of identifying things. So with language. So
I see,
piano, light, whatever. And so some of the people in the intelligence committee saw this, and they were like, "Let's talk." And we were tasked.
We've been watching it.
Probably. So we were actually tasked to put these models into a small, at the time it was a Jetson. They had Jetson NX at the time, and we were like, you can't do that. Like
Yeah.
it's running on this huge A100 and so forth, and I don't think A100s existed at the time, but it was the predecessor of that. So. And basically, we were able to do it in 12 months.
Wow.
And so we were able to put this large model into a small, Jetson, and we were able to put it on drones, on satellites, and so forth. And that was one of our early breaks.
Yes.
And so that it fueled the research, fueled the development of what we're doing, and so forth, and it also kind of made us more disciplined in how we approach these problems.
But detection is just one piece of the pie,
Exactly.
right?
So if you're detecting what's on the ground,
Yeah.
or fire detection and so forth, that's one piece of the pie. It's an important piece, but
Yeah.
you also need the response.
Yeah.
And so you see this in every industry that we've been in. Like you have the detection, yes, okay, but what am I going to do with this? What's the response going to be? So the response has to go, if it's inventory, it has to go into the ordering system. If it's early detection of fire, the drones have to work.
That's a good point.
Yeah. So the response. So all this is, in our journey, we've seen like, yes, this AI piece of it, the vision piece of it is very, very important, but it also has to be end to end in that sense, where the response has to come through. So it has to come full circle, and some of that dependency is not.
Yeah.
It's like
Sure.
there are other people
But
doing it.
but they still need to function together. I heard this story on September 12th, 2001. Everybody's feeling very patriotic, and everybody wanted to go buy an American flag. Well, you had Home Depot, you had Walmart, you had all these big box stores, and almost all of them ran out, except I think it was Home Depot, who had implemented a just-in-time ordering system. Once the stock went down past a certain amount, so they kicked off an automatic order, and then they made like hundreds of millions of dollars over the next weeks on selling flags, because they were the only game in town. So it seems to be, obviously that's a supply chain space versus like fire detection, or some of these cooler applications that Chooch is working
We
on.
do supply chain a lot. We do inventory management.
Oh, really?
So yeah. And
So
that's
what
one of
is
our big, yeah.
what does that look like in the next like 6 months? Like
6 months is.
you're like, you might as well say the next 20 years. Okay, fine.
Well, it's high level automation.
Okay.
That's what it is. I mean, you're
Yeah.
using Vision AI, you're using all kinds of systems to
Yeah.
automate the process. So you want, kind of humans to be out of that loop because human labor is expensive and it's
Yeah.
dirty. I mean, it's in the sense that
Sure.
it's kind of messy.
Yeah. And
You make
dull.
mistakes,
Dangerous, dull, and dirty is
people
probably a
don't-
lot of
people
the stuff you
don't do
guys
that
are.
work, and yeah, and so
Yeah.
and people get blamed for a lot of stuff. So you want you want to be able to automate all that, and the end result is efficiency and productivity, and that cascades through the organization.
Right. Let's get back to the models because you mentioned fine tuning, but that to me almost feels static. Like if you look at the bucket of say augmentation, that means fresh data that's coming in. Are those two kind of sole and separate, or how are you thinking about those as far as model performance?
So, I mean, in the classic sense, like the older computer vision models, you had to kind of collect a lot of data to even get to a certain level of accuracy, even 60, 70% accuracy. These are old, TensorFlow based, models, YOLO, and so forth. That's it, and these are still being used today, but they're used as components of the larger model.
I see.
The large vision models, which are like the same as the large language models, it's the equivalent, those are those need to be trained by these larger companies. The Microsoft's OpenAI's,
Sure.
Gemini's. It's not something you can actually go and train at a startup.
Sure.
You can fine tune it. And this is kind of the the fallacy around it. It's like, well, I've trained my own model. Well, you probably fine tuned it. If you're training an older type of object detector, yes, you can do that from scratch most of the time. But even there, you have transfer learning as well.
Yeah.
So the augmentation of new data is very, very important. But doing any of these from scratch doesn't make any sense anymore because you have other people kind of doing it. It's open source.
With like a hellacious amount of
Right. They've got billions of
resources.
dollars doing this, so
Yeah.
why would you try and do it from scratch? I mean, it's all open anyway. So what you have to do is you have to customize it.
Yeah.
And then you have to put layers of other models on it. So a lot of these, even the vision models, they don't work that well without the object detectors or the image classifiers. They still need this because if you're let's say looking down from space
Yeah.
onto the ground, you're going to see houses, cars, and so forth. Now, the large vision model isn't going to detect the individual pieces of it. There's some object detector large vision models that are up and running a little bit right now. But it's mainly the object detectors that detect the specific things on the ground,
Yeah.
and then the large vision model provides more detail about those specific things. So it's a layered approach, and this is one of our patents as well.
Ah. So, but I'm so curious, Emrah, is there a specific decision tree of like, if this happens, then you need to use this model, or because it's probably like I don't know, like a quarterback that's deciding
Yes.
who to throw the ball to.
Yeah.
How
So
does that work
it's
from a?
expert in models, and that was our initial patents. It was we realized that this is a big problem. You cannot like put everything into one model. It doesn't make sense.
Yeah.
Like it costs a lot.
Sure.
Train it again and so forth. So it's like you have one parent model
Yeah.
that does the orchestration,
Yeah.
and then it sends it to smaller models.
Interesting.
Yeah.
Yeah.
So this is kind of where vision is today. However, like even that, like if you do it too deterministically,
Yeah.
you won't get to the right to the right type of accuracies as
These
well.
are
So
hallucinations.
yeah,
Or?
and it might send it to the wrong model. 1 out of every 20 times, and
Yeah.
you're in trouble there.
I-
So it really depends on the use case.
Yeah.
So if the use case is really critical, then the guardrails have to be really tough on that. But that's the state of the art. Is like expert in models. You have an orchestrator, and we saw that with some of these other language models that came out.
Walk us through what the aha moment was, like, because some of these patents, like dynamically deciding what models to use, like that's like out of it's like sci-fi almost.
We had no choice. It's like it didn't work.
Yeah.
Like if something doesn't work, you're going to be like,
We got to fix it. Yeah.
So you have to kind of iterate on that. But
Can I ask you a question about that? So when we think about like iteration for like the innovation process for model building. Like, are you doing that on a whiteboard, or do you have an idea and then you test it, or can you kind of like simplify and talk us through what that process is like?
Very little whiteboarding.
Okay.
It's like, I have an idea, okay, test it out. You have like an hour.
Okay.
Like, that's how it works. And I mean, it has to be very quick.
Yeah.
And, it's kind of sloppy. I mean, it's not, all word,
Well,
kind of
innovation is, it's creativity, right?
we've been in the field for more than a decade.
Yeah.
With this. So it's all got to be very quick.
Sure.
You don't have that much time. But one of the aha moments with this was something very simple like facial recognition.
Yeah.
It was like, this is early 2010s. Even license plates reading is like, wow, whoa, this is like you can actually do this with machines. And then you're like, okay, well, if I can recognize faces, I can recognize everything.
Yeah.
And then I can do this with that. I can do.
Oh, it leads to the next application.
You're like thinking of the future, and like you can do so many things with vision AI.
It's a little Orwellian.
That's intuitive.
Yeah.
But it's not practical.
Yeah.
So you're like, intuitively, yes, you're going to get to that place at some point in the future, right?
And it's always so obvious in retrospect.
Yeah.
Like, of course the dots are connected like
Right,
this.
but it doesn't go that way, because you have market dynamics that play with, you have infrastructure issues,
Policy
issues,
Yeah.
you've got model issues, accuracy issues, and so forth. So this has been in the works, I would say, as a field since about 2007.
Yeah.
I'd say the ImageNet moment when, Fei Li and Ilya Sutskever and all these guys started collecting data in Stanford in 2007. That was that kind of moment where it started.
Yeah.
I would say this evolution of computer vision. Yeah.
So there must have been like, you must have known you struck gold. And I don't mean necessarily just from a like financial perspective, but like moving the progress of humanity forward, like codifying image detection and then layering on like you're saying, natural language processing so you could communicate and make requests. That's just, it's like shocking. It's shocking.
I mean, fundamentally, yes. And, the gold isn't there yet because it's still in its kind of infancy.
Yeah.
I mean, you see it with, I'd say the best like computer vision use case today is probably self-driving cars.
Mm-hmm.
I mean, that it's an end-to-end solution.
On the edge.
Yeah, on the edge, yes, largely on the edge and so forth. So that's one piece, and it's kind of in its infancy, even the best product. So you're like looking at this from a futuristic standpoint, and so yes, I mean, if we can put human cognition, scale it into machines, then we're going to know more about ourselves too.
Yeah.
Because there's so many things we miss as well.
Yeah.
We can't. I mean, you have all these cameras and no one's looking at them, and there's all this content that no one's kind of reviewing. Meta just, they moved all their content moderation into
like
AI right now.
Like Twitter, right?
Yeah.
Or
X. Just
I think.
recently, yeah. So that's a great case of how this is working. But yeah, I mean, I don't know if we're moving humanity forward, but humanity is changing.
Yeah.
I mean, what we're doing, we're changing. We're evolving, and there's something there to be said about like how efficiency and productivity come through. And I think we're on the right side of this in terms of economics, productivity, and efficiency. I'm not too sure about the mental aspect of it, and the spiritual aspect.
Ramifications.
Yeah, because we're not evolved to kind of be bombarded by this much information.
Yeah, it's funny you mention that, Emrah, because I heard that what's it called when you can the guy that deciphered the German wartime codes. It's supposed to be when you can't tell if it's a human or a computer.
The Turing.
Thank you. Yeah. So my understanding is that we've moved the goalposts on the Turing test because we're pretty much there.
Yeah.
But it would be just too monumental, like too heavy for us to actually process that we're getting into this new chapter of reality.
Yes. It's very exciting.
Yeah.
It's very exciting. I think net positive, probably come out of this, but we'll see. I mean, as we move forward, it's if you look at all the metrics over the last 100 years or so, like most metrics have improved.
Yeah. Oh, yeah. For like the average standard of living.
Average person, yeah.
Yeah.
I mean, if you look at it, objectively, the problem is our perception of it. Because we're
Like our shared vision,
yeah,
maybe.
yeah, shared vision. I mean, relatively, it's improved, but then you have you're perceiving things differently
Yeah.
as well. So our go back to this whole idea of like seeing, and then you have the language processing in your head, and then you have the models of belief systems in your head as well that are changing, and so. That's where that's where
That's philosophy.
That's I think that's where the fundamental problem is.
Okay.
And yeah, one of the fundamental issues is like how do we make our models a little bit more robust and not so edgy and not so
Oh, our models.
Yes.
Oh, maybe meditation.
Yeah,
Or
meditation.
like hanging out with Jeff. Jeff and Sylvia, and delicious food with friends. So like kind of getting back to the hallucination piece, Emrah, my understanding is that if you run a problem through a model and it gives you errors, one way you can do it is run it through multiple times, or break the problem in 2 or in 3 and then process it, and there's going to be less problems. How does that work in computer vision? Can you give us like a practical example of how we can decrease the error rate to have a better outcome?
Yeah. I mean, it's almost the same as in language, but it's a little different because you have to give it context about what it's looking at. So if it's, let's say, looking at bins, for example, you have to say, you're looking at bins.
Sure.
That's your first prompt.
Yeah.
And I want you to count how many products are on these bins.
Yeah.
And give me any. So you break it down. You first say, okay, what product do you see? And then it's a multiple prompt process. And then you could use multiple, large vision models at the same time. So if you just say, like, give me a count of this without proper prompting or proper, the steps that go into that, you're going to get a lot of more falses.
Yeah.
And so it's very similar to the language piece, but you have to give it a little bit more context and a little bit more layers over there as well.
And then there's a pretty interesting applications with biometrics. Like I heard in Japan, I think there's the smile police, where the photo booths won't take a picture of you unless you're actually smiling. You probably heard of something silly like this.
Biometrics is well advanced, right? It's probably the most advanced piece of computer vision today, and it's because people have been working on it for more than 3 decades. It's the face, it's kind of it's a simpler type of model.
I see.
And so that it's very advanced. It can understand pretty much anything that facial recognition, and facial recognition companies are also they're kind of situated differently. But we've done all of it. Like we've
I see.
done facial as well. So it's an earlier iteration of computer vision, and that's why it's so advanced.
Yeah.
Is that
because we've had more time to
iterate on it.
So so you're being in the enterprise space, that's like super fascinating, because I feel like there's a lot more resources to solve real business challenges. So that kind of tends to like move the needle. Yeah. You mentioned that defense was kind of like an early application. It'll be interesting when computer vision starts to get pushed like through the consumer play. But also like if we think, maybe you could even maybe you could even figure out like when somebody is like burnt out, and then you could recommend for them to take a vacation. Because there's probably like, if somebody's at the computer and they're doing this and they're angry and they're upset, the camera could likely pick that up. Yeah. And then rather than have them quit, you say, you know what, go hang out in Turkey. Yeah. Right. Yeah, which is, I think you're headed for a turkey trip pretty soon, right? Yeah.
These are popular, unpopular applications because it's kind of surveillance. We've had customers where trying to do employee productivity detection and so forth. This goes into the productivity of that. And so it's you got to be careful because it's a
People don't want to be watched.
the bosses businesses for them, like for the owners it's popular,
Yeah.
for the general public it's unpopular because it's surveillance.
Yeah.
And you're kind of micromanaging people, and so or you micro effect. So and this gets into the policy thing where
Yeah.
we're seeing more policy come out, AI policy and so forth. So I'm more of a free thinker in this. It's like, let things happen, and let the market kind of adjust. But maybe we do need some guardrails around that.
So being the chairman of, I mean, you guys came out within a couple days of OpenAI. So like you're kind of the first big successful company in the space. How do you feel, or where do you sit on driving innovation, but also still respecting privacy? I know it's kind of a curveball.
Yeah, there's a real, I mean, the in the new world we're going into, there's less privacy.
And people are okay with that,
And there's more
right?
transparency,
Yeah.
privacy, and it seems like people are okay with it to a certain extent.
Yeah.
You do have this, moment where you go, well, why did this ad show up? Like,
Yeah.
I only talked about it, like, I never tweeted or
Yeah.
whatever. And so you have these odd moments. And so I think, that train is left.
Yeah.
Yeah. And
It's like it's a runaway train.
yeah, it's a runaway train.
Yeah.
And so we need to be really careful about like how we definitely need the innovation. We need to progress. We need these models to become better,
Yeah.
more accurate. We need the safeguards around it. We need the safety around it. And so there's this delicate balance there. And I'm not an expert in that, but it's something that these other bigger folks are working on.
Yeah. Yeah. Because it's almost like you can't put the genie back in the bottle, like you mentioned. But on one hand, it's almost like we want to keep going as fast as we can because there's potentially national security concerns. Like if China develops a technology before us and then it starts to proliferate throughout the rest of the world, and then we're kind of laggards in that innovation that could have like downstream effects, right?
Yeah, I mean,
Yeah.
there's competition.
Yeah.
So you need to move.
Yeah.
Because the thing about this is like, there are breakouts and then breakdowns. If you're not ahead in this field, you're going to break down
Yeah.
because the competition will get ahead, and then it's all about economics, price, demand, and supply, and then you're going to be basically out of business. And this is the same with enterprises as well. They need to move forward. If they don't, they're going to be, sidestepped by some smaller guy somewhere. And so we need to be fast.
Yeah.
We do need to be fast. But
Yeah.
then, okay, what about these other things? And it's like, well, is it an afterthought? No. But like, how do you compete globally when it's like environmental issues as well? We have lots of environmental regulations, but it's kind of constricted the West in that sense over the last 20 years. And then you have these developing countries who don't care about it, and then they've kind of taken another. So
Sure.
it's similar with AI. We need to be really thoughtful about how we address that.
But that's not necessarily, I mean, not that there's like fault, but like, for example, when China got brought into the World Trade Organization, I think it was like 2002 or something, they were given the distinction of a developing nation. So they had a lot more lackadaisical rules and regulations and capital payback premises. So, I mean, it almost feels like the U.S. has held ourselves to a higher bar.
Yes.
And is that is that a good thing, do you think, overall? Because the flip side is it's allowed for China to become a real player on the global stage, and we're kind of in like this hot war, cold war kind of.
You can do both, right? You can have areas where you let free, like kind of zones where you can test and do things that, and you can have higher standards as well. I don't think, I mean, higher standards are good.
Kind of like mutually, yeah.
Yeah, but then you need to have areas where it's like some of these larger companies where you have once you scale up, like the larger, the big seven and so forth. How do you retain that startup vibe?
Yeah.
So what they do is they break up people into different groups and they operate like
Oh,
companies.
yeah.
So if you have like breakaway places in the U.S. where they can do whatever they want, and then they come back when they've found something or that's of interest. So
That's a pretty cool idea.
Kind of cleaned it up.
I think Jeff Bezos calls that the pizza rule, right?
Yeah, yeah.
If your team is larger than what it takes to feed folks for like a large pizza, it's like your team's too big.
Your team's too big.
Yeah. Do you implement a same kind of? I mean, I guess open the kimono a little bit on how your company thinks about innovation. Is it is there's like a lot of flexibility to kind of do your own thing and then come back? So there's like heavy research oriented, or is it more like let's collectively decide which directions we want to head and then we'll kind of pursue that together?
We're pretty independent group. I mean, developers and business people alike. We kind of go our own way and then come back and then
I see.
you know we let kind of the market decide and then internal like sessions decide where we go as well. But we want people to iterate.
Yeah.
You need to try something. If you don't try it, you'll never know.
Yeah.
So if you
Just like
you have an idea,
scientists.
yeah,
Yeah.
just test your idea, but test it quickly. Don't take 6 months to test an idea.
Yeah.
You test it today.
Yeah.
Like if you can.
Yeah.
You don't want to waste more time on it if it doesn't work. So it's about iteration.
Yeah.
This is like, it's very statistical in that sense. You try 99 things and the 100th thing works.
Yeah.
You need to get to that 100,
Yeah.
right? So you need to be able to test many things at the same time. So
Was this something that you had kind of developed this philosophy with mentors, or you've just seen it work in other organizations, or maybe unpack, like, tell us a little bit about your background and how you got to where you are.
yeah. Well, I've been an entrepreneur basically since college, and so real
Thank you.
real world businesses and developing these businesses from scratch almost all the time in strange places like Turkey and like that Middle East area, Central Asia as well. So that that kind of gives you some type of intuition, and we talk about the models in our heads. Like
Yeah.
that was piece of it. Like it was like, well, you better be fast on your feet,
Yeah.
be street smart, and you should also iterate as much as you can.
Yeah, that's
don't-
fine-tuning,
don't
right?
be- fine tuning.
Yeah.
That's what we call it now in Silicon Valley.
Yeah.
Fine-tuning. But it's actually iteration, and don't be afraid of failure, because every failure gets you a little bit closer
Yeah.
to success.
Yeah.
That's if you look at it that way, then you're going to have more success in the long run.
Yeah.
So it's statistically speaking, and you got to be able to kind of be persistent and weather the storm and so forth. There are many storms that happen, and it's difficult being a founder, being an entrepreneur. They're everything kind of
Yeah.
collapses on you.
Yeah. It's Elon says it's like chewing glass and staring into the abyss, right? So I mean, that tells me that you must really care about the problem that you're solving, or I guess it's not even like a singular problem, because it's like, in fact, by creating product, you're almost creating problems, because now as a society we need to address these new innovations. Like privacy is a perfect
Right.
example, right?
Well, it's I don't know. It's more like an obsession.
Okay. That means you're the right guy for the job.
I mean, it's like you need to be obsessed with what you're doing.
Yeah.
And the thing is, if you're not kind of obsessed, you're going to fail, because you're going to run into problems like almost every week.
Yeah.
And maybe every day. And so you need to be really obsessed about solving the problem and focus on the problem itself. And I mean, that's part of the journey. I mean, if you don't I think that's fundamental to being like kind of a pioneer in any space.
It almost feels like you've got a lens upon which you're seeing life or reality, and everything that you're taking in through that lens is through the idea of, I wonder how it could relate back to like solving computer vision, or what are the new applications, or is overcoming that hurdle maybe similar to something that we've seen internally, and we could reapply that in a new way. That's kind of like an intersection where you get like quantum leaps in innovation, right?
You're filtering everything you see.
Filter, that's
filtering with your model.
Yeah.
And it, there are some problems with that because you kind of get
Skewed.
biased, skewed. You're like totally obsessed by this thing that doesn't really matter that much. I mean,
Yeah.
it could be, there could be but those small problems add up.
Yeah.
And so you want to solve for each of those small problems.
What were some of the early wins and early mistakes that really like kind of shook the company or bolstered the company?
Well, I think we were early in the field,
Yeah.
and we, you know, being early in the field it's about timing, like, right time, right space, so forth. We underestimated like the infrastructure requirements.
Energy and
Well,
compute.
servers, compute, yeah.
Okay.
And the cameras, obviously, right, because that's what we do. And then the second thing I think we underestimated was the accuracy of the models, especially the old systems.
You thought they were better than they were.
We thought we could get it to yeah, and that's kind of,
That's good. That's a good thing because
Well,
if it was too difficult, you probably wouldn't have tried to.
no, exactly. And,
Yeah.
that's kind of the entrepreneur's, delusion.
You mean we're crazy?
You're like, well, I mean, you kind of, you're too optimistic
Yeah.
about things. You're like, well, I could solve that, It's
Yeah.
kind of this kind of thing that you have. And then, so it took a long time
Yeah.
to get the infrastructure and then the models. And then the third issue were the business cases. I mean, where are the real business cases?
Sure.
So our initial client was a visual search, but then, it wasn't it didn't go into production because the models weren't good enough. And
Yeah.
then no one had the compute, the client included. They didn't have the compute for this. And so, you have to kind of wait because that's not what you do, or you do it yourself. You try and do it. If you're a big guy,
Sure.
you can try and do it yourself.
Yeah.
But then, what we did was we kind of waited it out a little bit. The business cases weren't there either initially. I mean, smart city is not really a good business case because,
It's just too big of a bite to chew, or.
well, I mean, you have to prove the ROI.
Oh yeah.
So the ROI, I mean, slip and fall, theft detection, all this is kind of, for a city, not for enterprise.
Yeah.
The business cases whittled down, the use cases kind of came down. We filtered them out over the years, and so we focused on a few good use cases, very niche, that worked for us, and that's kind of how we survived and how we flourished until today. But it's a difficult ride because like the infrastructure stuff came later. Like NVIDIA, we started our partnership with them back in 2019, 2020.
Yeah.
And then that continued. And then the models as well, we use our own models and we also use open source models as well. Those developed over time. Those became more accurate. And so when you have this type of iteration as an ecosystem, it becomes easier to become successful in some of these use cases.
I can see all sorts of really interesting applications with like Anduril, or what's that cool company that Peter Thiel started? That's
Palantir.
like Palantir.
Yeah.
That feels like maybe like a pretty solid, because you guys are at the tip of the spear, and image processing and layered with natural language. I mean, that's just got.
We're the software layer, and a lot of these companies they try and do it themselves right now. But at the end of the day, you need to have specific expertise in that field as a company. You need to have it kind of in the DNA.
Right, and maybe the relationships with the people that are going to help.
Exactly.
Yeah.
Exactly. So we've integrated with Palantir and Anduril. I mean, we've done that.
Oh, okay.
In the past, yeah.
Cool.
So
It's probably not public.
yeah, no, but I mean, some of it is. But,
Yeah.
At the end of the day, a lot. It's there. The category, the computer vision category, is still kind of in its nascent stage.
Sure.
So we're leaders in that category. We're number one, number two in the category, and so that needs to kind of we need to keep iterating on some of these, and then you have that success as you move forward.
It's almost like a like it's good to be early, but even if you're early, you need to kind of continue that momentum until we get into more like widespread adoption.
Yes.
Like if you first there's the irrational exuberance, and then the trough of disillusionment, and then it starts to maybe like more kind of broader adoption, and then levels off. This is like the kind of curve of innovation,
so
right?
computer vision went through the, that phase in 2017, 2018.
Okay, about the same time as the transformer.
Yeah, well, no, it went through, it hit the trough.
Oh, okay.
Hit the trough last year.
Yeah.
I mean, the LLMs like hit the trough maybe this year, last year.
Yeah.
It's like, well, these aren't accurate enough. Like,
Sure.
it's hallucinating. And so, you want to adopt this, but like, I can't use it in broad, like enterprise production because it's not good enough. And
Yeah.
we've been through that process. We went through that process in 2017, 2018.
I see.
It was like the time where it kind of, and then now it's coming out.
Oh,
Yeah.
well, the perfect timing. I mean,
Well, we'll see.
yeah.
I mean, if you look at all the, Gartner, Forrester, all these analysts, they're saying.
Saying
we're-
Chooch is the
Well, and we're coming out of that phase, but we'll see. I mean, intuitively, it still makes a lot of sense, and we think that's also very critical for the next phase of development, which I believe
robotics.
is robotics. Yeah.
Robotics, okay.
I mean, we can finally do robotics with the current AI models,
Yeah.
language and vision combined, to a point where it works to a certain extent. I mean, the first one is, I'll say it again, is self-driving.
Yeah.
Autonomous driving is a robot.
Yeah. It's not the humanoid.
It's not the humanoid. It doesn't matter. I mean, maybe a lot of these won't be humanoids.
Yeah.
But we're talking about kind of automation of that type of movement.
Yeah. Like
in
specific to like one application, but it does that better than.
field, it could be used in agriculture and manufacturing.
But I mean, you have to admit, Emrah, like the world is built for humans. So building a humanoid robot. I mean, when do you think robotics plus computer vision is going to?
I don't know if this is the right form factor. Like,
I think it's great. Well, touche.
is this the right form factor for help?
I did see a robot walking across the street. We had NWA and Wu-Tang on like about a month ago in LA. And we were driving down West Hollywood Boulevard, and there's a robot like walking by itself. It wasn't the GT. You remember that one, right? It wasn't the not Megatron. It wasn't Tesla's, but it was like one of the other ones. But it was bipedal. It had a normal gait.
Yeah.
It was just like shocking. I was like, is this real?
Well, we're kind of obsessed with this humanoid.
Yeah. Why do you? What's the psychology behind that? Maybe it's the next iteration of humanity.
It's a copy of us.
Oh yeah. Okay, that's
We're
true.
copying everything. We copy the human factor as well.
Yeah.
I don't know if that's necessary.
Yeah.
I mean, maybe in some cases, but
Yeah.
in some use cases, yes. But I mean, yeah.
Maybe for
it's interesting.
like appendages.
Yeah.
Yeah. So you mentioned you mentioned large language models or LLMs, kind of in the trough of disillusionment. Jan LeCun agrees with you.
Yeah.
In fact, he was just saying a couple weeks ago, he's like, I'm really not so fascinated with those anymore. Have you ever met Jan?
No.
What do you think? Because I know you're kind of in the space.
Same space. Yeah.
Yeah.
But
What do you think comes
I think he has
next?
He's a little pessimistic in that sense, but
Like a doomer kind of thing?
no. I mean, he's a realistic, like kind of. I mean, because he's a scientist.
Sure.
It's like
He's a counterweight to the irrational exuberance.
We're the irrational.
Good.
He's rational.
Good. But again, we need that,
Yeah.
right? Yeah.
I mean, you need it. So, yes, but no. Like, there is, it doesn't work as well as you think it does. It hallucinates with big data. It's, kind of, it's sloppy. It's not. And there are ways to get through this, but we've been through this in vision. It's like, well, I'll do multiple models.
Just throw compute.
I'll throw more compute at it. It doesn't really work.
Yeah.
But the models are getting better.
Yeah.
It's like 3x every year, 4x every year. So you have the compute getting better, 3-4x. You have the server farms, like the 100 megawatt, 300. We're talking about huge.
And the chips,
The
like
chips,
from the H100
Yeah.
Compared to the Blackwell, it's like,
B100, B300,
yeah.
whatever.
I think that's like 100x
Yeah. So
improvement, right?
Today, yes, but like in 6 months, we're going to be talking something else. Like,
Yeah.
Yeah. So I think, we're getting there in that sense. But this is a faster iteration.
Yeah.
I think. I mean, last year models were not that good. I mean, like,
Yeah, do you remember the Will Smith eating spaghetti?
Yeah.
It's like, that's just crazy looking. And now it's like pretty damn good. Yeah.
So, I mean, just because we're in this, you have a phase of this, Moore's law still exists.
Yeah.
And it's a double every 24 months. Now we're like tripling every year. So it's even faster than Moore's law. So yes, there's some disillusionment, but ultimately, like,
And collectively,
Yeah,
the compounding innovation.
nothing. Yeah, I mean, like this is here to stay. It's real, and you better get on it.
Yeah.
Yeah.
Yeah. But you have to admit, like, it can be a little bit difficult to fathom, especially for folks that are not in the computer vision or maybe like even in the AI space. Like, it took us 66 years from when the Wright brothers first took flight. I think Kitty Hawk was the name of the plane. And then 66 years later, we were on the moon. So that just feels like almost like a quantum leap and not that long, right? So when we look back and we had the steam engine like 150 years ago, and 20 years ago we had DVDs, and now we're getting artificial general intelligence. So what? 6 months, 12 months, 18 months? What do you think? Maybe we should define AGI.
Yeah, I don't know what AGI is, but I think we're almost. I mean, we're pretty much there in a very basic level.
Yeah.
Very basic level. We're about there. But you mentioned something very important. And that was how did this happen? Like we go from like Wright brothers to moon.
Yeah.
I mean, within 100 and 150 years, and before then we were horse carriages for 10,000 years.
Yeah.
Whatever. Like. So something anomalous is happening to us as humans. I think it's important to recognize that first, like on the macro stage, like macro, understand that something weird is happening with humanity itself. Because if you don't put that into perspective, then you can't really make sense of what's happening today, and you're going to get overwhelmed and think this is something normal. We're actually in an abnormal stage in history. Like, it's not normal. Like nothing now is kind of like ordinary.
Yeah. It's exciting now.
Well, it's exciting, and it could be overwhelming for a lot of people.
Yeah.
And people can feel left behind and all that kind of stuff going on. So we need to have some type of balance there and try and say, well, yes, what we're going through is not normal.
Yeah.
And start with that. And
So what do we do with that information aside from maybe be a little bit kinder to our fellow humans?
Yeah, I mean, kinder is one thing. I'm more worried about like competition.
Can you
being more competitive?
Can you expand a little bit?
Well, I mean, I think in terms of like how we do things, like how we work, how we communicate. We need to be able to adapt the newest tools to be able to compete with other people and with other organizations and other countries as well.
I see.
And so it's not about like, okay, let's be kind to each other. Yes, that's definitely. But then, like, how do we adapt everything very quickly so that we can stay ahead? And the reason you want to stay ahead is because there's an existential threat
if we don't.
If you don't.
Yeah.
If personally too, like, I mean, this is it's very personal.
Sure.
If you don't adapt with these new tools,
yeah,
you're not going to be able to, like, survive.
You're like, I'm never using email.
Like, you'll not make it.
Yeah.
And so there's that, but understanding that, okay, we're living through abnormal times, and I'm going to try and iterate on this like on a daily basis.
Yeah.
And focus on that in order to be able to survive. I mean, it's evolutionary, like it's Darwinism at its like very like fundamental. Like.
Emrah, you seem so grounded, and for somebody who's helping run like arguably one of the most innovative companies in the most innovative spaces in the most innovative places in the world, you feel very grounded. Are you spiritual, or do you meditate? Do you spend a lot of time with your family? How do you kind of keep those two things sold separate so you stay sane?
Well, I mean, it's a lot of it has to do with like kind of survival techniques.
You're like, I'm doing this because I have to.
You can either stay sane or not stay sane.
Yeah. I'll
Like,
pick
I
the
gotta
first
pick
one.
sane. How do I do that? Like,
Okay.
well, then I have to kind of dismiss and compartmentalize.
So it's almost like not probabilistic. But
No,
it's,
you got to be like, okay, this is something else, and be like, I'm a big believer in stoicism.
okay.
So
Cool.
Marcus Aurelius,
Yeah.
like you can't, you have control over yourself of how you react to things, not like you don't have much,
Yeah.
you can't control the world. That's the thing. Like, so you have to be kind of like,
Yeah.
separate yourself from yourself, and then separate yourself from the world.
Have you read Meditations?
Yes.
It was so fascinating to me. Like, that was never meant to be read publicly. That were like notes for himself.
So imagine that, like
Yeah.
2,300 years ago,
Yeah.
right? It's like same problems. Like, we haven't changed. Like, humans haven't changed. We have the same problems then, same problems today.
Well,
Yeah.
our hardware may not have changed, but the software has.
Software, well, that's the thing. That's the thing. Like, you've changed the software,
But the hardware's still catching up.
The hardware's, back there.
Yeah.
And you're having problems.
Yeah.
You're having serious problems.
When do we when do we get a hardware upgrade? When do we become cyborgs?
Hopefully we are sort of like, if you need your phone,
Yeah.
computer everywhere. So
Yeah, but that's not natively built, right? I could take my phone and kind of like toss it over there, right?
you don't though. You cannot.
That's true.
Yeah, you don't live without your phone for a day. So it's almost like an appendage right now. Right? So you already have kind of this.
Yeah.
We're already kind of in the cyborg phase.
And it's more powerful than the computers that put us on the moon.
Yes. Yeah. So we're already kind of in this early cyborg phase.
Yeah.
And I think with the coming, AGI and robotics revolution, it's going to be more. And we need it. We need it desperately for efficiency and productivity reasons, and because we have aging demographics as well. So
Oh, yeah. 10,000 people a day turn 60 in the U.S. I just read. So it's kind of changing the scope of the demographics, right?
Because people are getting older, there needs to be more efficiency in the system to be able to take care of her and take care and pay actually with for the population.
Yeah.
And so I think we desperately need AGI. We desperately need, especially in the next 10, 20 years, robotics to stay to maintain our lifestyles and to be able to be efficient. Yeah. And that's another thing. Like, if you think of the macro effect of that, we're not going to have enough people to work at some stage in the future, just because the demographics. This is excluding Africa, though.
Sure.
Africa's different, and I know you have experience with Africa. Tell us a little bit about that.
Sure. Yeah, it was kind of interesting. My friend Musa Dow and his brother Aruna grew up in Côte d'Ivoire near Abidjan. And the cool thing is when he mentioned that he has a good relationship with President Aoele, they came over to the U.S. or to Silicon Valley, and we had a show. I think it was episode number 94 or something like that, and that was just a really cool experience to explore the intersection of improving a nation and then having the ability to impact policy. Because, I mean, it's so much deeper than that, though, Emrah. Like, if we look here, specifically like in the Bay Area, but to a larger degree the US, if we see something that is not going great, we look at that and we go, hey, there's an opportunity to fix it. And then maybe we could create a company around that product or that service. In Africa, I think there's, of course, you can't paint with a super broad brush, but how across all the countries across Africa, how they see the relationship between the government and the people, it feels a little bit more contentious. Mm-hmm. It's more like, I don't want to break those rules because there could be retribution, as opposed to like misfortune breeds opportunity. And, you know, maybe that's $1 billion idea to kind of move the needle. But President Aka has a very different philosophy, one of empowerment and recognizing that it's not just in the Côte d'Ivoire, but all across the continent. You know, 8 of the 10 fastest growing countries are in Africa. So like you've got a younger demographic who's getting online, who's teaching themselves, and they're hungry for opportunity. It just feels like a tremendous boon that's going to be exploding in a beautiful way.
Yeah, that's why I said excluding Africa.
Yeah.
Their demographics looks really solid.
Yeah.
For the next at least 50, 60 years.
Yeah.
So, that's going to be where a lot of opportunity will be, I think.
Yeah.
In the future.
Absolutely. How can maybe share a website for us?
Chooch.com.
Chooch.com. CHOOCH.com. And then for the zombie community, how can we help you? Who's the perfect introduction to help drive new revenue, or what would that look like?
Yeah, I meet people all the time. So I mean, it's not really. We talk to venture capitalists, large organizations,
Yeah.
who people who really are passionate about this and want to deploy it.
Yeah.
Those are the people I want to talk to.
Okay. Well, shout out to Stephen Longley. You got to meet Longley Capital. These guys are fantastic, and I think right up your alley. So
thank you.
That could be great. Well, hey, this has been so fun. Emrah, really appreciate it. Okay, cool. And for more of the best brains, check out siliconzombies.com. And also want to do a shout out to our friends at Necodex. That's NECODEX for if you're building a mobile product or web product or design. These guys are the ones to talk to, and we'll include their information in the show notes. But thanks so much, and we'll see you next week.